All right, this is our first lesson. Today our objective is going to be that by the end of this lesson you'll be able to write mathematical equations and expressions and specifically use variables to represent unknowns. You'll know you're successful when you can read a written statement, turn it into a mathematical expression using variables. So today we're going to review some vocabulary on the next slide. We're going to go over a little discussion question. We're going to do, I think, 3, maybe 4 examples. You'll do your exercises, your problem set. This will serve as your exit ticket today. Okay, so this will be your ET, your exit ticket. It's what will be graded, and we'll do a little closure and reflection where you kind of respond to classmates about the lesson in Google Classroom. All right, so this lesson 1 of Module 4 builds on things you learned in 6th grade and 7th grade regarding taking sentences that are written as word sentences and turning them into mathematical equations and expressions. We're going to be using variables today, but I also want to hone in on some vocabulary words that I review that you need to know what these words mean because we want to be able to take these words and put them into mathematical symbols. So for example, the word sum. We know that when we see the word sum, that means we are going to be adding, okay? Difference. When we see difference, we're going to be subtracting. Quotient means we are dividing. We're going to be using fractions more often than not, rather than this division sign. Squared. This is when we raise something to the power of 2. That's an exponent of 2. That's the same thing as saying x times itself. Remember, that does not mean x times 2. It means x times itself twice. Cubed is when you raise something to the power of 3, which means x times itself 3 times in this case. Combined is when we're taking two things and adding them together. So this is another word for addition. Consecutive. This is a super important word for today's lesson and for moving forward. So consecutive is just like one right after the next. So if I have consecutive numbers, here's some consecutive numbers right here. 1, 2, 3, 4. They're right after each other. If I said consecutive even numbers, here are some consecutive even numbers. Let's start with 4. The next even number after 4 is 6. The next even number after 6 is 8. So those are consecutive even numbers, and we would do the same thing for odd numbers, right? I'll start with 11. That's an odd number. The next odd number after that would be 13. The next odd number after that would be 15. And the one thing you want to note about this is if we're just doing consecutive numbers, we're just adding 1 each time, right? We're adding 1 each time to get to the next consecutive number. When we're doing consecutive even numbers, we're adding 2 each time, okay, to get to the next consecutive even number. And same with our odds. We're also adding 2 each time because we're just skipping a space, right? So that's something to keep in mind as we move forward. And then, not lastly, because I want to add one more on here, is. When we see the word is, that means equals, okay? So if I say the sum of 2 and 2 is, basically that means the sum of 2 and 2 equals 4, okay? And then the last one I want to make sure I remember to point out is product. Product means multiplication. Now, we're not probably going to use the dot. More often than not, we're going to use parentheses to represent multiplication. So just to remind you, say I want to do 3 times 4. I'm no longer going to use that x because x represents a variable now. I'm either going to do 3 times 4 with the dot, or I'm just going to do 3 parentheses 4, because when two numbers or two terms are directly adjacent to one another with a parentheses, that means multiplication. Okay, so that's just a review before we get into our work today. All right, I'm not going to go too much in depth with this first discussion question because it is super difficult, but basically this is just showing you what we're going to be able to do by the end of the lesson. We're going to be able to take a sentence and then turn that into a mathematical equation. So I'm just going to go through and point out what they've done here without really explaining how they've done it. I'm going to explain more about how we do this process when we go through the examples in just a moment, okay? So I'm just going to point it out every single part of this equation. The number 1,157, so that is represented here, is, we just talked about that means equals, the sum of, we have the sum of, so we have an addition sign, the squares of 2 consecutive odd integers. So this is our unknown here, so that's why it's a variable. The squares, so we have the squares of two consecutive odd integers. So we have x and then x plus 2 representing those two consecutive odd integers. Because the first one, we don't know what it is, but we know that the second one is going to be 2 numbers away from that one, okay? And then it goes on to say divided by. So this is our division symbol, just written as a fraction. The difference means subtraction. We have that subtraction sign here. The two consecutive odd integers. So it's the same integers from before, but when we do subtraction, we do the bigger number first. So we're taking this x plus 2 first and subtracting that x. So essentially this is what you're going to be doing today. You're going to be reading a sentence like this. And after we, close read it, talk about the different words, what they mean, define our unknown variable, we will be able to put it into a representation like this. All right, this is the first example we're going to do. And anytime you guys come to a word problem this year, I want you to make these 3 boxes so we can close read it. Close reading is super important in math because it helps you really figure out what you're being asked to do and figure out what you should do first, what certain words mean, etc. It helps you understand the question more. So I suggest you do this each and every time you encounter a word problem. The first time we read, we're just reading for the big idea. So it says, we want to express the following statement using symbolic language. A whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. Now, after reading that, I hear a lot of things that I do understand, like words like whole number. I know that's just a number that's not a fraction or a decimal. Square, that means to the second power. Half, that's when you divide something by 2. Subtracted 5 times. Okay, so I know what those words mean. I'm not sure I know exactly what to do first, but I know it's asking me to take that sentence and put it into a mathematical equation or expression. Okay, so the second time we read, we're actually going to annotate. We're going to write things in, draw things, make note of things, circle, etc. I'm going to start here. The second time it says a whole number. So even right there, I know that a whole number is a number that's not a decimal or a fraction. Okay, so a whole number has the property that when something's squared, that means it's raised to the second power. So I'm just going to make a note of that. Second power. When the square of half the number, when I have a number, when I cut it in half, that means I'm dividing it by 2. Okay, is subtracted, pretty self-explanatory, subtracted from, so being taken away from this, from 5 times the number, so whatever the number is, don't know what it is, times 5, we get the number itself. And when it says we get the number itself, that means the answer is the number itself. Okay, so that's our like equal sign. That's where that's going to be. Okay, so I've gone through, I've written down what some of these keywords mean. I feel like I understand a little bit more. Maybe not knowing exactly what I should do first, second, third, etc. But I understand some of the components that are going to be written out here. Okay, now the third time I read, and especially for these, we want to figure out what is it asking us? What do we not know? And for these questions, we definitely want to figure out what is our unknown? What is our variable? What do we not know? So I'm going to write this down because we need to define it. Before we start solving, we have to define our unknown variable. So it says a whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. So the thing that I don't know here is the number. It doesn't give me any number. It just says the number, right? The number, the number, the number. I don't know what that is. So the number is going to be my unknown variable. And I'm going to call that number x, because if we don't know what it is, we have to use a letter to represent whatever it could be. So I've read for my third time. I have defined my unknown variable, and I'm done with my close reading. Now that I have my unknown variable, I have the different operations I'm going to use. I'm going to go in and just start writing this out starting at the beginning. Okay? I'm going to use red to show this. So starting at the beginning again, a whole number. And we said we're going to call that So this whole number x, it has a property that when the square of half of that number, so when we do the square of half of this, so as you can see, I just divided this by 2. That makes it halved. And we're taking the square of that. So I just basically wrote down this. The square of half that number. I just represented that with my red pen. Is subtracted from. So we're taking this away from something. We're taking this square of half this number x away from 5 times the number. So it's going to be 5 times something. What is it going to be 5 times? The number. Do we have a number? No. What did we say that was? X. So it's going to be 5 times this number x. And when we take away the square of half the number from 5 times the number, we get, or it equals, the number itself. So this is how we're going to go about solving these problems today. Breaking it down, close reading, going through, and writing our answer. Now the last thing I want to do before I leave this page is I'm going to check and make sure I have every single piece of this sentence represented. So I'm going to say a whole number has the property that when the square of half the number is represented right here. Square of half the number is subtracted from. Here's my subtraction sign right here. Is subtracted from 5 times the number. There's 5 times the number. We get, that's my equal sign, the number itself. So I have just proved that I represented all of that, okay? And we are done with this first example. All right, example 2, we're going to go ahead and just start by making our boxes to show that we need to close read. And we start, we want to express the following statement in symbolic language. Paulo has a certain amount of money. If he spends $6, then he has a quarter of the original amount left. So I heard phrases that stick out to me. I understand that this guy is dealing with money. He spent some. He has so much left. Okay? I'm going to go in and read for a second time and highlight some things, write some things in, okay? Starting here. Paulo has a certain amount of money. It doesn't tell me how much he has, so that's probably going to be my unknown, is how much money he has. He starts off with, okay? He spends $6. When you spend money, you're subtracting it. So he spends $6. Then he has 1/4 of the original amount left. So this is what it equals after he spends the $6, okay? This is what it equals after he spends the $6. It equals 1/4 of whatever the original amount was, okay? And I have read for my second time. I've done some annotations. The third time I'm reading, I am looking for that unknown variable. I need to define it. Okay, it says Paulo has a certain amount of money. That is what I don't know, is how much money does he have to begin with. So this is my unknown, okay? So let's just call that M. So this is what is considered defining the variable. We say that the variable represents the amount of money. And we're going to call this variable M, okay? So he spends $6, so we do M, take away that $6, and then he has 1/4 of the original amount left. Again, the original amount is M. So both of these places are going to be represented by my variable M. I think I'm ready to go and get started writing this problem out. All right, I'm going to start with just the beginning. Paulo has a certain amount of money. We say he has this much money, M dollars. He's then going to spend $6. So we're going to take $6 away from that. And when we take that away, he then has, so basically that equals 1/4 of the original amount of money he started with, which is 1/4 of the amount of money he started with. Now, before I'm done, I want to check to make sure I've represented every part of this in my answer. We're just going to go through one more time and do it. Paulo has a certain amount of money, okay? He spends $6. Spends is our subtraction sign, and 6 is $6. Then he has, so then that equals 1/4 of, which means times, of the original amount, which was M. And we are done here. All right, we're going to do 2 more examples. Here is our third one. Got my boxes ready. And I'm just going to start here because we know the first part already. Just says basically write it in mathematical language. The sum of 3 consecutive integers is 372. This is pretty straightforward, kind of the shortest one we've done so far. Okay, I'm going to go through and annotate this second time. The sum means we are adding. The sum of tells us what we're going to be adding. So it says the sum of 3 consecutive integers. So we talked about this before. 3 numbers, consecutive, back to back to back. Example of consecutive integers would be 1, 2, 3. Okay? Not saying that those are the ones that we're using, just saying that's an example of them. Is, this word is means equals. And obviously our equals is 372. Okay, I have read for my second time. Now I'm ready to read for my third time and define my unknown variable. What do we not know here? What information is missing? Okay, the sum of 3 consecutive integers is 372. So the only piece of information I don't know for sure is what are these integers. So these are going to be my variables, okay? So the unknown variable are the 3, consecutive integers. And let's just call these x, okay? Obviously, each one of those numbers cannot be x, because if it was all x, then it would be the same number, not 3 consecutive numbers. When we have consecutive numbers, you can see they're getting bigger each time. Each time they're increasing by 1. So the first one would be x, right? Our first number would be x. Our second number, the one that comes after x, would be x plus 1. Okay? And then the third consecutive integer would be x plus 2. And I'm going to put these in parentheses just so that we keep them together, right? So that is what a consecutive integer looks like. We start off, the next one we're just going to be adding 1 to the original. The next one we're going to be adding 2 to the original because we're 2 spaces away. So I've defined my unknown variable. I am ready to get started writing this. All right, it says the sum of 3 consecutive integers. So I know I'm going to be adding 3 things. So I have 3 places ready to be added. Is, so it equals 372. Now, the integers are consecutive. I'm starting with my variables because that's my unknown. The first one is going to be x. The second one is just going to be 1 more than x. And the third one is going to be 2 more than x. Okay? And this is my answer. I'm going to check one time to make sure I have every component here. But this one's pretty short and sweet, so I know that I do. All right, the sum, we have plus signs of 3 consecutive integers, x, x plus 1, x plus 2, those are my 3 consecutive integers, is 372, and we are done here. All right, last example. This one is very similar to the one before. The only difference is that instead of just regular consecutive integers, it's consecutive odd integers. Let's go ahead and read. It says the sum of 3 consecutive odd integers is 93. All right, again, just going through really quickly. I'm just going to do this as fast as I can. Sum 3 consecutive odd integers is 93. And what all this means is plus 3 consecutive odd integers, it would be something like 1, 3, 5, right? So it's an example. Again, not saying that's the numbers we're going to use. Is equals 93. Okay? Done with my second read. Third read, I'm going to define my unknown variable. All right. It says the sum of 3 consecutive odd integers is 93. What we don't know here is what are these 3 consecutive odd integers. So this is what we're going to have to define. And again, I'm just going to use x here, okay, to define these 3 consecutive odd integers. Now, if we look at my example of odd integers up here, you can see that they are being added by 2 each time. Anytime we're doing consecutive odd integers, we add 2 each time. So where my first consecutive odd integer is x, the next one is going to be whatever x is plus 2. So it's going to be x plus 2. Okay? And then my third consecutive odd integer is going to be whatever that x is plus 4, because if you look right here in my example, to go from 1 to 5, we add 4. So the last one is going to be x plus 4. Okay, and I'm going to mark off my third box because I'm done with my close reading. I've defined my variable and I am ready to solve. So it says the sum of 3 consecutive odd integers. So I have 2 plus signs because I'm adding 3 numbers is or equals 93. And we already went through into this. The first one is x, the next one is x plus 2, and the third one is x plus 4 because these are odd. Okay, this is my answer. I'm going to check it to make sure everything is represented. We have the sum of 3 consecutive odd integers, here are my 3 ones, is 93. And we are done here. All right, for these exercises, you are going to do them on your own. These are the ones that you are going to do. Let's see. I want you to do number 1. I want you to do number 3. And I want you to do number 4. So you do not need to do number 2. You do not need to do number 5. When you have finished these 3, please come back to this and watch me explain them. All right, so I am going to explain these 3. I'm going to do it pretty quickly, just kind of writing in. I'm not going to close read each one just for the sake of time. You should have done that on your own. So the sum of 4 consecutive even integers is negative 128. We have the sum of 1, 2, 3, 4 integers is or equals negative 28. When I go in and I'm looking at even integers, I'll start with just x. You could use a different variable if you wanted. Whatever your second term is going to be whatever that first one is plus 2. Okay? The next one is going to be whatever that first one was plus 4. And the next one is going to be whatever that first one is plus 6. And this is your answer. It's the sum of 4 consecutive and even integers, and it equals negative 28. Okay? Number 3, Stephen has some money. We don't know how much. That's our variable. If he spends $9, then he will have 3/5 of the amount he started with. That's what we don't know, is the amount he started with. So I'm going to use that as M for money. So Stephen starts out with some money. He spends $9. And then he has, or now, that equals 3/5 of whatever he started with. That is our answer for number 3. Number 4, the sum of a number squared and 3 less than twice the number is 129. So we're doing the sum of a number squared and 3 less than twice the number. And then we have is 129. So these are our 3 parts. So we're doing a sum of this and this, okay? What we don't know is what that number is. That's going to be our variable. I'm just going to use n. So the sum of the number n squared and 3 less, so we're taking away 3. 3 less than, this is less than twice the number n, so 2n is or equals 129. And that's it for our exercises. All right, so for your problem set today, you're not going to be doing all of these for a grade. I'm going to circle the ones that you're going to do. So we're going to be doing number 3. Number 5. And number 7. So 3, 5, and 7 are the questions you're going to be doing for a grade today. Please make sure that with each question you close read. So I want to make sure that I see evidence that you have 3 boxes marked. You've marked up your problem. I can see that you've annotated, okay? And to get full credit, you also need to define your unknown variable for each question as well. Okay? Again, this is going to be your first graded assignment for this module. So please make sure you follow all the directions. And again, you're only doing 3, 5, and 7. All right, so just to summarize this lesson before you go on to your independent practice, you want to make sure that you begin every single word problem by defining your unknown variable. That makes it so much easier moving forward, saying this is representing this, and I'm going to use this letter for it. Okay? Keep in mind that we can use different symbols. If I use a P and you use an A, and we're writing an equation to represent the same word problem, those can still both be correct, okay? And lastly, just make sure that you're breaking these problems down into smaller parts. Try working them with simpler numbers. So this is where our close reading comes in. It's super important in math to close read so that we know that what we're doing, the order that we're doing it in, and we're not getting so confused. And so I guess before you move on to your independent practice, make sure you're always doing your close reading and make sure you are defining your unknown variables. And you should be good.